Okay, that'll get you guys up here. Get you in here with me. And then we can zoom you right down in here to work. All right, guys, so we're going to show you. Oh, I've already got it fixed, but I want to walk you all through it and then show you how these circuits work. So this is the Power Pump 100. So right now, let's just take you over here. There's going to be a bunch of moving you guys around so you can see we have everything off. So this is the Power Pump 100. This is on the amplifier test bench. As you can see, we got the Power Pump 100. It's hooked. We have the Galaxy 33 transmitter on the bench coming over here, feeding the input of the amplifier. And the amplifier output comes over, goes to the 500 bird dummy load. And all the tests, yada, 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 so on, down the line, all the equipment. Okay, so enough of that. We're going to come right over here, and I'm going to show you. First thing we're going to show you is the pass-through. Well, what is the pass-through? Pass-through is the ability for the RF to go into the amplifier and come out. So we're going to start out forward. We're going to go to SWR and reverse. This is going to set that forward and reverse on the meter. Let me reach over. We're on the low side, so we're going to key the transmitter, and we're going to tune. All right. Let me turn this. I'm going to show you. So now we're going to put it on, and we're going to set this. So we're keying up. Oh, I didn't show you all that. I got ahead of myself. Let's go to forward, power, 10-watt scale. And so this is the power from the Galaxy 33. So that's 1 watt. With the carrier on. So basically, I set them up at 0.8. So there's 3/4 of a watt dead key, right? You see it on the screen, right? 3/4 of a watt dead key. So now we're going to reach over here. We're going to turn this little Power Pump 100 on. We're on low. We're going to come right up here. We're going to put it on forward. We're going to put it on reverse and SWR. We're going to key, forward and SWR. And we're going to key and tune to set, which is right here. Now we're going to flip it to reflect. And this is the pass-through of the amplifier. Look how clean this amplifier is, guys. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, let me bring up the reference so we can actually see the characteristics of the amplifier on the scope or on the spectrum. So let me reach over you, hit the reference. We're going to key, and we're going to run this reference up, and we're going to look at this amplifier signal. Damn, what a clean amplifier. Okay. Keep looking at the spectrum screen. That's carrier with the amplifier on low. Pay attention to the white. Man, that is superb. Now, what I want you guys to do now is I'm going to turn the amplifier off. Pay attention to the size of the yellow. We're going to set that 1 watt or 3/4 watt carrier to 2 division. So there's 2 divisions on the screen. 2 divisions on the screen. We're over here. Now we're going to go back and span back. This is radio power only. We're now on the 10-watt scale, and we're going forward, power. There's your 1 watt or 3/4 of a watt. Now we're going to leave it on the 10 watt scale, and I want to show you this cool characteristic here. So now we're going to reach back, turn the amplifier on, and we're on low. Now 3/4 of a watt input drive. Look where we set at carrier. So 3/4 of the watt input drive is making 7.5 watts carrier power. Now this is RMS only, true RMS only. Come back over here to the scope. That's the amplifier on in low. Look at that dadgum voltage over time. That is extremely clean amplifier. I'm impressed. Now we're going to come back, span it back down. We're going to reach down so you can see. We're going to turn it to the 100 watt scale. Remember, this is true RMS power here, guys. Now we're on a 100 watt scale. So you see the 100 watt scale. Dead center of the screen is 50, right where that 6 is. Ready? So now you're going to see the same characteristic of about that 7.5 watt dead key down here. Ain't that beautiful? First flash is, that's beautiful. Now, let's see what it'll do. Remember, this is true average only. We're on a low power, and this is true average. Carrier. Adios, worldwide, worldwide, worldwide. Oh, Ford RMS. 1, 2, 1, 2. So we're keying 7 average. Adios. Swinging 50 average. You know how loud that is, ladies and gentlemen? 7 average on the carrier. 50 average on the swing. Now that's low. Now that's so damn awesome. Come back over here. There's your 7 watts carrier. Worldwide, 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 worldwide. Break, 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 break. Now, we're going to take you right back to the meter. We're on a 100 watt scale now. And we're going to go to high power. High power. Still putting the same amount of drive. And let's see what we go. Let's see if that 7 watts comes up some. High power. Adios. Adios. Oh, there's a big difference. Let's see here. Nope. And that's what I'm trying to, what we're looking at here. So, I don't know. Okay, there's low. All right. So we got something going on here. And I think I already probably know what it is, just from experience. So we'll come back to the amplifier. So what I'm looking at, guys, is when we switch from low to high power, our carrier ratios aren't changing. So we've got to look. So how these circuits work, and I like to teach, so let me get over here so I can really teach this. Because if you can't see it, you won't understand anything I'm showing you. And it's going to be really hard to even show it from this angle, but I can talk you through it so you'll understand. All right. So I'm going to, I've already tested the switch. I kind of did some things ahead at the time because that's how I do. What I'm concerned about is I'm going to look at the schematic and find out what this resistor is supposed to be at. It's at 51.4 ohms, which to me makes a lot of sense because here's what's happening. When you're on low, the switch is down, and then the down position, the signal is bypassing the resistor, meaning that the direct drive from the radio comes in straight up, comes in, and what it does is it bypasses the resistor, comes in and hits the input by going through this input cap. Now, there they are right there. Okay. I'm wanting to see what the shunt. So when we switch, we're not getting any differences of voltage division. In other words, we're not getting the characteristics of high and low. No matter if it's on high power or low power, it's still keying 7 watts and swinging 55 average, which is well over 100 watts peak. And it's working flawlessly. But we're not getting voltage division. In other words, we're not getting the pads not coming in. So I want to check and to determine that with switch is even good. Because we just have something simple going on. So we're going to come and we're going to probe the top pin of the switch, which is connected in series with the resistor. Then we're going to come here. So the resistor is not open. Now we're going to come and make sure by taking this positive leg and going to the bottom pin, or we can go to the input trace and switch between the two, and we should tone off and on. Excuse me, there's decoupling. Okay, right here, we should switch off and on. So I'm going to switch with my pinky. That switch is good. Okay, next thing, we're going to go to automatic capacitance. We're going to check, or excuse me, wrong. We're going to go to automatic resistance, and we're going to check and measure the resistance. Now, we should really lift one leg of the resistor. But because of the way the circuit's decoupled and open here, it should not affect at all. Understanding the circuit is what we're doing here. So if you look at the meter, And I'm just going to probe across. I got that on meg ohm. There we go. So we're just going to probe across the resistor. Not there. Here we go. Sorry, guys. Okay. I'm going to show you. So it's 51.4 ohms. I'll show you all what I'm talking about. Make sure, okay, y'all can see it. So have a look at the. Now you got to give it time to load. So have a look here. So we're 51.34223, 51.2 ohms. Okay, now I want to check this coupling capacitor, which okay. Beautiful. So coupling capacitor is good. That one's good. That one's good. That one's good. That one's good. Should be a trace. There it is. There it is. Here. .222. That's wild. Okay. Let's see what's on this capacitor. This mica. For something. I think it's for something. All right. The 470, my picofarad capacitor, which I need to lift the leg. We have really good. I'm thinking Let's see, we got green, brown, black, gold. And then we got perfect. It's got a little bit of delay. It's only got 47 of delay. And then this is for the there's all the receive control. This is the preamp. This is the keying circuit. This is the preamplifier. I'll be damned. I just found it. I'll be damned. I gotta show. I just found it right here on video. I'll be damned. Just found it right on video. And that's why I show this stuff. Look at this. Now, I want you guys to comment. First person that can comment in the video gets a treat. It's going to be hard to see. But I found the problem. Just had to study the circuit. And I'm going to put you guys right on it here. Yeah, I got to come like right up on it. I found it. I found the direct problem. We'll be able to fix it within 2 minutes. It's right there. You see it? Who can see it, guys? So it's the bottom spade that comes off the switch, that bypasses the voltage divider, guys. Look at the spade. Anybody see it? So here's the top spade. The top spade takes the 51.4 ohm resistor to ground. So when you're in high, it's putting pad on your input. But look down below. That's hooked straight to the switch, and it goes right here. It's broke. And that's why we don't have any voltage division from high to low. Now, if my damn camera would freaking lock right there for me, it's not. So I'll just have to zoom way back out. But let me get in here and really look it over with my, oh my gosh, my boom's hung up in my shoestrings. Oh, I know what to do. We'll drop the boom and zoom you all right in here. That's it. I mean, that's the absolute only thing it could be. Now that I've verified that everything else is working. Now let's get in here and let's look at this together. See it? All right. So there's the switch, and I'm going to move the white wire. Should I move it up? Oh, the cap's in the way, so you can see it coming off there. There's the blocker. My Jesus. There it is. There it is. Look right here, guys. There's one leg. And there's the other leg. See it? Someone's clipped it. Is what they've done. So they can trim. So they don't have any. You see what I'm saying? Making it not have a voltage divider. I don't know if you guys can see it, but I do for sure. Here's the end of the leg that gets soldered. And then right over here, it's still tying into the same input. Now you can see it. Now can't you see it, folks? So look at the end of my tweezers. This leg. And if we move the silver mica back, look at that. That leg and ties in there. What someone's done is just cut it out. So what we're going to do is make a jumper, verify on the equipment that we're getting voltage division, padding, which this is a voltage divider, this big green fit resistor. So what we need to do, I've been studying this one for a second and I just found the damn problem. Cool. So now we can hook. Then we can come. So we can hook one leg. Make sure we're not touching. Let's see. We can come on this side of the resistor, and that'll be the same thing as a bypass. I just don't like. Oh, my hands are so big, guys. Come on. Yeah, it's not going to grab that. Just give me a second here. Like, I can't work with and video at the same time. You guys are in my way. God. I am so not set up for this stuff, guys, to be recording. I could show you all so much shit if I could just record what I'm doing half the time. But there it is. Clean as day. Let me just get in here and fix it. There's no sense to show you anymore. It's obvious what's going on. Let's just fix it. Now it's completely on the other side of that big resistor. So you won't be able to see absolutely nothing I'm doing. But just understand that actually, it looks like it's been modified now that I'm looking at it. Yeah, because they've bypassed. So if I hook that up, it's high. Well, it damn sure did go there. Now, I need to study this a minute. We got something going, some weird shit going on here. Looks like somebody's modified it, is what they've done. That's definitely it. So let me do a test here real quick. Let's see. I wonder if I could do this littler one. Yep, that works. That works. And what I'll do is I'll just touch it. Let me fire things up here, see where we're on. Let's go. Let's go. That'll be fine. We'll turn that on. Turn the amp on. We're in a little. Okay, so low power, it ain't gonna get. It won't change. Let me see. Until I touch. Let me see where we're at here. Make sure. That's our big carrier. So. There it is. That's it. We got it. Good God Almighty! It slammed the scale. That's it. All right. Let's fix it. That is definitely it. That broke, I guess. I don't know what, or either broke or someone cut it because they wanted to. Yep. All right. Let's fire up the gun. Good deal. I like fixing amplifiers, finding out the problem. Sometimes you just got to take your time. So now we're going to go right around here. I'll let you all watch me fix this dude. So we're going to be working right in front of where these two caps. Uh-oh, my damn boom just broke. Can you believe it? That's all right. We ain't going to let it overcome us. Hang tight, guys. We definitely got it figured out. We definitely got it. That's awesome. Now, we'll just keep on humping along. I got to get you guys over here where I can work. I want to raise the boom. But I like for y'all to be able to watch. Y'all have to understand that I've got a little one-bedroom house, man. I don't have no damn room for a quarter of the stuff I got. A quarter of it. So we're going to come in here and fix it. Thanks for hanging out. Thanks for putting up with all the bad camera. But there's a lot I can teach and show, man. I'm thinking I want to come from this side. I want you to see what I'm doing, but it's going to be hard because it's tucked underneath a bunch of stuff. See, it is no matter where I come, you're not going to be able to see what I'm doing. You're just not. There's too much going on. But if I come over here, you'll be able to see some of it the best. I'm working right behind that green resistor. That 50, measuring out 54.1 ohms, but that's in circuit. All right, so let's get us I think what I'll use is we won't need, but let me snip off a little piece of heavy resistor leg or something like that. Just take an old component leg. I only need a short piece, but I want it to be a heavier. God, I've got to clean my lab, guys. I do so much repair, and I've got so much crap. Jesus. Freaking ridiculous how much shit I have. All right, so we're going to cut. We're going to leave us a little leg right there. We're going to use that for our jumper. Boy, this thing's got some high power now. That thing jumped up real big because it was being sent through that resistor all the time. All right. Now we got a eye carrier. We won't need this resistor. And power supply's off. Radio's off, but that won't matter. And let's come over the top. A little bit of solder. First thing we do. There we go. There we go. Now we'll do surgery. Make sure that that's tied into the input good. Beautiful. I can literally move the amplifier with it. Now we're going to take our tag wire. We're going to take and pull it vertical and away. And then we're going to come underneath, pull our silver mica over. I'm going to turn my hemostats away from me, and then we're going to pull the tag wire from our switch up away from the board. Just like that. Now our tab is vertical. So now we can take our tie-in, put a little bend on it. Now we're going to grab this end and cut it off because we don't need all that ugly amount of wire. Just like that. So now we got that. Now we're going to come in. Clean the flux. Clean the flux around the pad. Make sure that we're not grounded out underneath the pad. Beautiful. Input wire is good. Decoupling is good. Electrolytics. Okay, now we're going to solder it and be done. And the way I'm going to be able to do that is it's going to be just real easy. I'm going to preload. Making sure everything's real pretty and clean. Now, I'm going to take you guys over here and show you. First, we'll do a couple of test hits. Let me get the test leads back on my meter here, and then we'll do a couple of test hits. But I know we got it because I test before I do it. That's just something that I've taught myself over the years. That's why we tested it first. That's why we do this stuff. Now, let's see if we got high and low power on this little amplifier we just rebuilt. Or we just repaired. So there's our radio on. We're going to grab this. They're going to come right over here, and I'm going to show you the work now before we show you the test. Now, unfortunately, to show you anything, you guys already know, you got to keep doing all this moving around crap, but I'm sorry, I don't have room. All right. So now if you look, and I'll move all the stuff around. Look right underneath that resistor. Let me move this stuff back. And we're going to come right over the top here. And look underneath that resistor. See where we joined and strapped? I'm going to touch it. We strapped. That's all. That's the bottom of the switch. We strapped it all the way back to our input. And our input, look at my tweezers. This is the input. comes in, and then it stops on a little island, and that switch is tied into that pad. And that input rail comes back, goes up, and goes into the relay. It goes out. Of course, it goes the opposite direction. All right. I know. Right there. See how I strapped it? So now, we're going to turn around, put you right back into the meter system. So we're on a 10-watt scale. We're going to go to 100. So we're looking at the bottom, 20, 40, 60, 80. We're going to turn it all on. Make sure it don't blow up in our face. It didn't. Preamps working, even though we don't have an antenna. All right. Galaxy 33, low steel. We're in low power. Low power. Freaking beautiful. I love what I do. Yeah. And high power. Anybody learning anything? So on low power, I now have it set up to where it's keying about 7.5. Ooh, right at 7. Yeah, that resistor is loading. So about 7.5 on the dead key. Oh, sent to the moon. 100 watt scale. Seven and a half to 55 average. High scale. Excuse me. High scale. Keying 25 average. Good God Almighty. You think I fixed it? Good God Almighty. That thing's doing 70 average. Let's go to the 500 watt scale. So we're reading the top. Let's see if we can make that go close to 100 watts. Adios. Adios. Let's see here. So it's 25. I forgot to set that. It's 25. Yeah, we need that. So and that's let's set it down. I'll show you what I'm talking about. I never, ever, 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 ever use that 500 watt scale. And I know how accurate. 25. Of course, on the 10, it's going to bury it. So there's about, let's see. So that's 30. There's 20, 21 and a half. Okay, yeah. So we're about 25, 27, 8 watts. 27. Check this out. Make sure I'm on the 500. I need to get my big tool here. Hold tight. There we go. I love this old equipment. So let's go. So there's 50. And then half of that would be 25. Right there. So there's 25 watt carrier. 25 watt carrier. All right, and that's how easy it is. All right. Now, let's get back on what we were showing. And I never use 500 average scale unless I'm setting an amplifier, and I recalibrated this thing about a year ago, and I never did. I only calibrated the 10 and 100 scale, and I just remembered that. Let's see here. So we'll go. I'll show you, in case you guys want to see that it's no bullshit, let me show you what I'm talking about. So we'll take the cable right out of the input of the amplifier, so you can see everything in real world time. So there's the amplifier. Hell, it's still on. Turn it off. We're going to take the green cable. It's coming straight from the Galaxy 33, going right into the input. Good God. Good God. Good God. Tell those are corroded. Haven't never had anything screwed into it in a while. Now we're going to take it, go right into the 1040. We're just going to bring this, go right into the output. Turn it on. Now we're going to bring new. Now we forget about the amplifier. Remember what I showed you the radio doing? Remember? 10 watt scale, average. Let's go ahead and set up the reflect. So we're going to go to set reflect. So you key it, set, reflect 1.01. Go back to forward power, 10 watt scale. And there's your exact 1 watt exact. And this is calibrated deadly accurate. Yes, it's an older piece of equipment. Deadly accurate. All right, so 50 watt scale. So 50 watt scale, you'll be reading the first lash after the 0. There it is. And 100 watt scale. 100 watt scale, meter full deflection is 100 watts, meaning that you'll be reading the first scribed marked. Pretty amazing, ain't it? All right. Back to the 50 watt scale. That means you'll be reading the first dash on the top line. Pretty amazing, ain't it? Okay. So nobody's pulling no wool over your eyes. Nothing goofy going on. I'm showing you real world stuff here. All right. So now we're going to disconnect out of the 10240. Go right back into the input of the amplifier, which on these will be on the left. So you guys that don't know, these are basically, it's just basically like a Palomar design. This is called the Power Pump 100. But if you want me to be honest with you, it's a lot like the Palomar TS 100. Now it's actually got a pretty cool design. Once we get settled here, I'm going to run you back through the whole amplifier again. So here is the test basis, or the characteristics of the test. We're setting at 14.2. That's 50 amps of supply. Set at 14.2. That is the Power Pump 100. We just rebuilt the voltage dividing circuit. Basically the high and low power. I'll let you really look at the amplifier here for a minute. So starting here at the back. Yes, those are replacement relays. That's why they're marked. This thing's been gone through. I need to clean the flux up. I'm actually going to do that. I just got through rebuilding all that front, that green resistor, all that. That's the voltage divider, the high and low. Sitting right underneath that 470 picofarad silver mica capacitor that's sitting towards the front, next to that 51.4 ohm resistor that you see at the front. That's the pad voltage divider. So now we're going to show you again. It's off. We're driving it with the Galaxy 33 with it's a 3 high, medium, and low. So it's got high, medium, and low. We're on low. I built this radio. So this radio keys exactly 1 watt on low. As I showed you all 100 times. We'll show you again. 10 watt scale. Reach over here and grab the radio. There's your 1 watt. Here's the radio's modulated signal in average. Adios. Adios. So we're only putting about 2 average into this freaking amplifier. 2 average watts into this amplifier. Okay, now we're going to move you over here to the amplifier. Reach up, turn it on. We're in low power. Now I'm going to walk you right away from the amplifier. We're going to go right back to the meter. Low power. This is all average. We're going to leave it on the 10 watt scale because how incredibly cool this input pad is on the front of this amplifier. We can make this thing key really nicely. 1 watt, well, 1 watt dead key into it. And it's going to produce with this front end pad and voltage divider. There's your 7 and some change, ain't it? Beautiful. 7 and some change on the carrier. Look at the scope. Beautiful, beautiful signal. Now I'm going to let you see the scope. I'm going to turn the amplifier off. That's on. That is off. That is on. Massive growth. Okay. Back to the basics. Radio out, radio power. 3/4 of a watt in. Amplifier on. 7 watts made. Can't modulate there because I'll slam that scale, go to the 100 watt scale. We're going to key that 7 watts back up. You're only going to see it moved about to the first lash. Adios. Then we'll modulate off that 7 watts. Adios. 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 1 2 1 2 1 2 1 2 1 1 1 1 1. Big RMS maker. Worldwide. That thing's absolutely getting it, guys. Keying 7.5 bird average, swinging 50 average. Adios. All right, that's low power. So that shows you that we have repaired the amplifier. So now we're going to come. I like to show everything, so don't be annoyed by all the back and forth. I show stuff. I like to show it instead of take something out of the box or whatever that make a 5-minute video of it working, explaining, and not showing nothing. I just like to show. I like to be a little different. I annoy a lot of people by all the back and forth shit, but I like to show stuff for people that are wanting to learn. So, high power. Now that we're on high power, obviously we can't come over here and key it up on a 10-watt scale at high power, because we know on low power it keys 7.5 average. So we got to jump up to the 100-watt scale. We jump up to the 100-watt scale, we're going to be looking down here. But I know this circuit and these two 455s on the high watt scale, on a high power with 1 watt of drive, you're going to key about 20 average, slightly over. I know that from years and years and years of doing this. Maybe 22, maybe 25. I'll be down. Ain't that incredible? All right, so we're keying 22 average. Adios! Adios! And that's a talking son of a gun right there. And gentlemen, adios! Adios! 1 2 1 2 1 2 1 2 1 2 1 2 1 2. So now if you come over here and you look at the oscilloscope and spectrometer, you're going to see a large growth of the signal. So we'll key. This is on the high power. So as you can see, we fill the whole entire scope. So we're going to come up here and we're going to turn that voltage. And we want to keep. And then we're going to come over here and we're going to turn our reference down to bring the signal into the screen. Just like that. So now we're on high power. 1 2 1 2 1 2 4 1 1 1 1 2 3 3 3 3 4 5. Now I know a lot of you are going to say, watch this before you got to run in your lips. Yeah. Thank you. That is a tone into the amplifier, and it is absolutely textbook. Clean, clean, clean. 1 kilohertz tone. This thing's doing 35 average on the tone, 40 average. It's absolutely working perfectly. Pretty awesome little repair. Fun. Once I determined what was going on, of course, it took me a minute to find it, but I found it right here on video together, so. Beautiful. Just barely warm. Absolutely perfect. Absolutely perfect. So I think while you guys are watching, I'll deflux it, clean it up a bit, vacuum it out, and we will put it back together. It is fixed. Just like that, my friends. So we'll turn the power off of it. We'll disconnect the inputs. It's funny how this thing's double threads on its. Alright guys, I sure do appreciate y'all watching me. I love to do this. Let's just leave that ground hooked to my system, my test supply for testing amplifiers. This. Alright. I'll jerk this off. A little test circuit here. Peanut, I wish you would stop. Peanut, that's enough. We're going to slap our top on it real quick. Let's just do that. What? Oh, durr. Stop. Peanut! No! Stop it! Anyways, another one done, guys. Just clean the flux and then we'll shop vac it. That's the modulation light shunt circuit. Push this decoupler over. All right, let's shop back this up and push the LEDs towards the front. She's good, man. She's ready to be wrapped up. I wonder if my little grommets will fit in those holes. Probably not. I hate when people drill holes in the radios like this, but when I do that, I gotta at least put some let's go shop. Let's go clean that up. All right, get my bench radio off my table. We'll go get my rig back in. Put this rig up. What you doing, boy? Besides chewing your shit all up. Alright, so we'll get you all some voice here. Besides my voice. I'm gonna go get the vacuum.
The only thing you can do, man, is just keep moving forward. You know, I gotta get off my dead ass sometimes and get things done. You know, like wash the dishes, mop the floors, clean all the appliances. Yeah, man. The cleaning lady, she left.
So that amplifier was only doing half of its power because of that voltage divider. It was only doing low power. I don't think the person knew half the power was being hidden behind that resistor.
Every now and then, you know, you gotta give a dog a moan. That's what I used to do.
That's why.
My lady didn't want to do nothing. I had to put a little pep in her step, man. I'll give the old lady a dog bone, and man, oh man, she was a cleaning, and she was doing everything. I even had her wash the car and wax it. What you think?
Shit. You're so full of shit. That thing's been through hell and back. It works good.
I want to hear it. Hell yeah.
All right.
I hear you, brother. All right, man. You take care, man. Have a good one. I'm sitting by, man. You're like solid 9, man. Mother Nature got her skirt up and her panties off. Have a good one. Peace. I'm sitting by. Alright, man, take care. I got some other people coming over to talk to you. I don't know if you can hear me or not, but they're kind of taking me out there a little bit. Taco Bell. Hell yeah, peace, brother. I'm going to get on out of here for a minute. Go get me a bottle of water. Peace out.
Well, there's another one fixed. Another one fixed. Just like that, guys. Fire Pump 100. What we do, man. Fix shit.
Hello. Hello. I hear somebody out here.
Now I got to go take care of this garden. Constant doing, always doing something. Then I'll come in here and chew the rag for a minute. Then I'll go lay down for the night. Then I'll get up and I'll build another radio in the morning. I got a 959 Bearcat, Cobra 29. Got an Eagle 350 I just rebuilt amplifier. I gotta put power cables. Thanks for watching my channel. And if you're still interested in watching it, I'll take you over here and put you right in. Okay, so where are you?
TQ, one radio, 582, stand man, standing by.
Thanks, guys. I ain't fucking doing this shit no more.